All right, greetings everyone. Welcome to our final presentations. Just as a reminder to everyone, this is actually live streaming, so please make sure that you are not displaying anything that you don't wish to be displayed or on mute if you do indeed need to be on mute. So what I'm going to do here is I'm going to change my background. There we go. Welcome, everyone. Welcome to the ISGEO-22 Workshop for Model-Based Reasoning final presentations. We have 4 teams that will be joining us today that will be presenting their results from their very hard work at this year's session. Now, I just want to double check on chat, make sure we are good to go, make sure there's anything. Okay, not a problem. Having said that, I want to give the order for today's presentation. So our order for today, we're actually going to start with pulling up my notes here just to be certain in our teams. There we go. And so today we will actually be starting with Team Semanta, and then we will be moving to Team Icebreaker, and then Team Hawaii, and then Team Onto-Somethin. I'm sorry, I think I did that in the wrong order. Let me do that one more time. We have Team Semanta, and then Team Hawaii, and then Team Onto-Somethin, and then Team Icebreaker, Team Icebreaker. Having said that, those that are joining us via YouTube, please feel free to click on the event site for ISGEO, and you can take a look at some of the teams' results on their GitHub repositories, as well as some of their findings and solutions as they've gone along throughout the week. So, having said that, I welcome you all, and I want to give a moment to our head honcho, or the person that one of the visionaries that actually started the intelligent systems for geosciences many years ago, Miss Suzanne, or Dr. Suzanne Pierce. So Suzanne, would you mind giving us a greeting, just saying hello to everyone this afternoon?
Sure. I'd just like to say welcome to all of you who are rejoining us or joining us for the first time to see the final session and the final presentations of our hackathon teams for the combined ISGEO and iHarp 2022 workshop series. I want to thank everyone who stuck with us this week throughout the virtual program. And for those of you who were able to join us for the various lectures and presentations, it's been a really informative process. And we've received a lot of support from many different members of communities, including the Intelligent Systems and Geosciences Research Coordination Network, the iHarp community, which is just forming, the Quasi and HydroShare community, as well as the Design Safe community. So I just want to say thank you to everyone who's been here and participated, contributed both by being present and engaged with conversations, as well as providing your knowledge and expertise to this community group. Things move on. This is just one of the ways that we communicate with each other. There will be many ways that we'll talk about at the end of the presentations, but you can always contribute and commit and connect with these communities. So we like to invite all comers, anyone who's interested in learning more and being part of the academic and intellectual dialogue. You are all welcome. And I particularly want to say thank you to Dr. Deanna Pennington for helping to coordinate us and design this workshop for us, and to Jamie Powell in particular for leading the implementation and pushing us through the schedule and the program and maintaining all of the Zooms and the GitHubs and the active links that were necessary to make this happen virtually. It's no small feat to design and implement and offer this workshop. And with that, I will turn it back over to you, Jimmy, and I'll let you follow on with the program.
Oh, thank you, Suzanne. I appreciate it. Again, though, if it were not for you, of course, none of this would be possible. So thank you so much. Having said that, I also want to take a moment to welcome Dr. Pennington. Deanna has been our session chair. She is the lead when it comes to the model-based reasoning, and she has really did, especially there in the beginning where we were really learning how to work with these interdisciplinary groups and whatnot. She's the one that guided us through that process. And so Dr. Pennington, if you wouldn't mind giving a welcome to us.
Well, welcome to everybody. Thank you, Suzanne and Jimmy, for all of the work you've done this week. It's certainly been interesting putting this whole thing together. Teamwork is really difficult to do virtually. So congratulations to all of you for sticking with it. I hope you had a really productive couple of days, and I'm looking forward to seeing what you came up with. And that's it for me.
Thank you so much. And thank you for all your work. The teams and I have all, we have very much enjoyed the various sessions that you've given us and given us the tools we need to be able to work across interdisciplinary fields. Anyone that's done that knows that that is a very difficult thing at times, learning each other's vocabulary and whatnot, but you definitely give us the tools to do that. So now, at long last, it is time for us to see what our teams have come up with. Now, this year, we have 4 teams. Those 4 teams were Team Semanta, Team Icebreaker, Team Onto-Somethin. No, let me back up. There we go. Team Semanta, Team Hawaii, Team Onto-Somethin, and then Team Icebreaker that have all put together some amazing work over the course of these couple days that they're going to present to you. But starting this out, we're going to have Team Semanta to present first. So Team Semanta, you have 10 minutes and the floor is yours.
Let me make sure that I'm unmuted. So hey everyone, I'm Lydia Fletcher once again. I'm from the Texas Advanced Computing Center at UT Austin, and I'm part of Team Semanta. Team Semanta robot emoji, to be very specific. Once again, I started by proposing an idea to look at what metadata is necessary or needed for doing semantic searching. And so that's basically when you're collecting GIS data, what is the metadata that you need to capture in order to enable kind of more advanced types of searching than just simply, your really basic descriptive metadata, searching based on title, creator, etc. And the kind of reasoning behind this is that I'm working on a project called the Texas Disaster Information System, along with several of my colleagues here in the conference. And we're looking at how we can use an ontological framework to map metadata fields across models and data sets that will facilitate model integration. And so one of the first things that I did was kind of try to explain, what are the different levels of metadata that we're talking about. So level 1 metadata is the stuff that everybody's used to. There goes my Outlook calendar telling me something's going on. Descriptive metadata is, title, creator, the really basic stuff that you're expecting to find in any kind of data registry or data repository. And level 2 metadata is what we were really focusing on for this project, which is figuring out what metadata you need that can facilitate that mapping process and facilitate semantic searching. We started out with 4 folks. Tabish ducked out after the first day. Will Mobley and I continued working on kind of the TDIS-centric side of things. And then Akila is a climate researcher. And so we tried to organize kind of 2 parallel paths where we were working on things that would aid her work and her research as a data scientist and as a climate change person, and ours, Will's and mine, on the Texas Disaster Information System. Some of the initial barriers that we had were that we have different definitions for things, and it actually really helped for us to kind of sit down and talk about, like, well, what do you mean when you say this? I mean this when I say this. And figure out, you know, that we were coming from different perspectives or different interpretations of the same words. Repository and catalog were words that we had very different ways of thinking about. Coming from a library science background, I have a very specific way of thinking about those. And so kind of getting us all on the same page and getting us all to kind of gel together where we agreed on those things was an initial barrier that we approached the first day. However, it was a really productive discussion, and we had really great communication among the team. And it was really helpful to have kind of a fresh perspective from Akila telling us about her work and what she really focuses on when she's looking for things. So initially, we kind of put together this concept map that pulled together both what kind of Will was working on in terms of decision making and support for decision making, as well as kind of Akila's side of things, where she particularly how she searches for things and what goes into finding those things, and then what gets done with those on the outcome part. So our initial goal and objective was to initiate an AI for climate science data discovery by kind of setting up a parallel software registry and data sources so that we could kind of begin to figure out how to tie those two things together so that we could search and get a return that was like, here's your model and here's the data that goes with that. This was the initial logic model that we put together on Tuesday morning, where we really kind of tried to tease out what our activities were going to be for the week, what metrics we were going to use, and what our short-term and long-term outcomes were, and what we thought the impact would be. And as Will is going to explain, we kind of hit some road bumps and refocused what we were going to be working on. So I'll let Will take over.
So on Wednesday, what we realized is that we did still have some definitions that were off. Registry and repository and catalog are very different things for us. And so we ended up spending several hours actually mapping out what those mean and how the linkages actually can work to start to actually query and get the right information from it. So when we came back for Wednesday, our initial goal was to actually make that legible and digitize it. And then we wanted to run a couple just examples, tests of the climate data sets, and ended up being some flood data sets as well as populating a specific software or modeling software into Onto-Soft to see how that was going to work. We brought in an expert to talk with us and tell us what worked, what didn't work, and had some questions about different things for us. So this is our legible image that we ended up generating. And so at the top, we can actually look at the linkages that you can go through an entire analysis, asking for funding, and going all the way to what data sets would be required for a specific type of analysis that would support a funding. We're going to care about everything in the square. Those will be the actual software, modeling software code, as well as the data sets that are required. And so from that, with the right metadata, we should be able to query registries for software and data, and be able to pick up and identify whether data is available at any given location within the state for that specific software. So we can move on. And so from that, we were actually able to work for the HEC-RAS modeling software and identify different data sets that should be able to work with it. And so this is where we also came up with a roadblock, which is that it is very difficult to identify some of these modeling software inputs based off of their user guides. Especially when it comes to like engineering inputs like HEC-RAS, they tell you a whole bunch of different things, and then you talk to an expert and they're like, no, it's these 7. and they simplify everything and it makes it very intuitive. I really don't understand why they had that, but I spent hours and then talked to him, and then we're able to find the data sets in about an hour. So we were able to generate this data registry, which just had the initial ones for HEC-RAS, and we can go ahead and move on. And then we were able to populate the software repository as well for one version of HEC-RAS, which was 6.2. And we found several things that worked really well and several things that didn't. And I'll let Lydia speak to those.
Yeah, so as we were going through the software registry, like Will mentioned, we worked with an expert from outside of our organization who works really specifically with this flood modeling software and data sets that are related to it. And as we were going through, we realized that there were some limitations with Onto-Soft that include things like this specific software. When you're working with one version of it, there are you can be working with 6.1, but 6.2 is also available. So maybe some people are using that. 6.1 and above has features enabled in it that HEC-RAS 5.x does not have. But some people are still using that. And then so figuring out if you could track all of those different versions in a single entry for HEC-RAS, or whether you needed to break them out into separate entries where you could look at each one and compare them based on their features, was one thing that we, kind of struggled with, as well as tracking things like backwards compatibility. So the outputs from a later version of HEC-RAS do not work with earlier versions of the software. And so there were, a variety of things that we kind of found with Onto-Soft were lacking, especially like Will mentioned, it's kind of difficult to find appropriate data sets that match with specific software sometimes. And so trying to figure out how to identify those and how to build the link between those so that you're getting an accurate recommendation when you're searching for a data set to use with a specific software is something that we're going to need to really work on.
All right, and we'll go to the next slide. And so from here, we've actually revised that map. And so we're going to be able to use that and start working with our team on how these metadata linkages work and actually be able to more formalize those processes. Once we have the registries actually built for the data catalog and for the software, once we explore some other repositories for the software as well, we'll actually be able to start to populate these things, which will allow us to finally implement what's actually going to happen, which is going to allow us to have a very robust query system for data sets required for specific analyses across the state. And so with that, are there any questions?
All right. Excellent job, team. Excellent job. And you all actually stayed on time wonderfully. So we do have time for questions. Are there any questions from the audience?
I just want to make a quick comment. I was interested to hear about the challenges you had overcoming vocabulary differences. I knew a team, an interdisciplinary team that spent 2 years working together before they figured out they were using the word model differently. And I myself have been on a team where we spent a full year trying to agree on what is a scientific observation. So those vocabulary things are amazingly difficult to get past.
Yeah, that was a large part of the conversation that Will and I had when we were trying to map out that new model of like how everything interacts, because we realized that not only was Will using terms different from how I was using words, but we were using those terms differently from how other people within our organization were using them. And so when we finally kind of agreed, like, oh, okay, this is what we mean when we say a data registry. This is what we mean when we say a software registry. Like now we have standardized those terms for our project, and we're going to make all of our teammates get on board and agree with that as well. So that when we say something like a data catalog or a model catalog, we all know exactly what we're talking about. So it was really, I mean, that was amazingly helpful because it was something that I think that we had, kind of not realized that we were all talking about different things until Will and I kind of sat down and were like, oh, well, this means this. Oh, I thought it meant this. Oh, no. Okay.
Yeah, well, that's why we spent so much time that first day talking about vocabulary issues and making sure that you're really aware of those. Because otherwise you just keep talking and you don't even notice it.
Yep. Yeah, it was super helpful. Incredibly helpful.
Excellent. An excellent job to the team. So I want to give them a hand. Thank you all so much for all your hard work. Thank you. And up next, we have Team Hawaii. Team Hawaii, the floor is yours.
Thank you, Jimmy. Aloha, everyone. We are Team Hawaii presenting you Threatened Paradise, mapping an invasive fern using machine learning. Here are our team members. I'm Yoko. My team members are Danielle, Lisa, and Joe. I'm very much fortunate to have wonderful suggestions and help from those experts coming from different backgrounds. I'm going over the problem here in Hawaii. Hawaiian vegetations have been threatened by a variety of human-induced forces. One of the problems is an invasive fern. This fern grows fast and aggressively outcompetes native ferns and other native plants in the tropical forest, so that these native ferns and other native plants are displaced. What this invasive fern does is that it blocks sunlight by forming dense canopies over the native ferns and the other native plants. The goal of this project is to map the invasive fern using machine learning object detection technique to assist land managers. Once a map is ready, the invasive fern can be quickly treated or removed efficiently and effectively. The study site is on the island of Oahu, where it's the middle of Pacific Ocean. As you see the map on the left upper side, that is a high-level view, including the mainland of California and the Hawaiian Island. And the main area consists of Oahu Island. It's zoomed up as we can understand the shape of the island. So this map illustrates the habitat status. Brown color area is a bare or less than 5% of vegetation. Purple is heavily disturbed. Yellow is native dominated. Interestingly, this habitat status will correlate with human activities. For example, the purple area are urbanized, where have road networks, housing, commercial buildings, etc. The red areas are on the mountain ridges. These areas are protected lands and nobody lives up there. The study area of this project is within the red area. This is a project logic model, which organizes the project logics from the very beginning to the end. First, obtaining image data, next, creating training data set, then use the machine learning models with multiple classifiers to train and test the data. After that, accuracy assessment on the prediction model is conducted. If the accuracy is not high enough, tune and train the model, and then repeat those steps until desired accuracy of the prediction model is achieved. Also, the training data set may be modified. After getting the prediction model, this will be transferred to a map. The map helps land manager to identify location of invasive fern so that they can effectively and efficiently manage the land. It eventually protects native ferns and other native plants. Next, I will show you a project timeline. So here is a detail of the project timeline. I have already obtained over 6,000 high-resolution aerial images and created over 1,000 bounding boxes over the target fern prior to this event. Through this hackathon, the third task is done. It is to write a Python code to generate training dataset by cropping image files by individual polygons. There are several tasks remaining that include not only programming tasks, but also writing up a proposal, accuracy assessment, and holding meetings with stakeholders. I feel comfortable to take this project moving forward by referring to this project timeline. The code along necessary image file and a polygon file have been added to the GitHub. I'd like to thank my team members for providing significant help, ISGEO and iHerb for organizing this virtual workshop and for providing the great learning opportunity, and today's audiences for listening to the project presentation. Thank you.
Fantastic, Yoko. And Team Hawaii, do you all have any questions for the team?
I have a question.
Yes,
Okay, can I go ahead?
Yes.
Okay. So I think I misunderstood, but I didn't understand that. So are you going to predict the fern locations for the future, or I mean, can you find the trend of the future that okay, this zone could be a danger zone, or you are talking about just now, or I mean, do you want to identify the fern locations in the earliest stage, or do you talk about the future?
I'm sorry, I think I used the incorrect term. Instead of prediction model, maybe detection model. So object detection model. Yeah, thank you for asking.
Talks about now, the location of now, yeah?
Yes,
but
correct.
I was to ask that which models did you use, and did you try graph neural networks? Because I think for like nodes could be locations, and each of them could have their own, you know, information as like time series or anything else. I want to know that did you also try graph neural networks, or which models, which types of machine learning models you use?
I have to evaluate the models, which model I'm going to use. One of the suggested model is YOLO version 6. And the other model probably will go with RCNN. However, I have to gather the journals to support which model I'm going to use.
Okay, so you just evaluated two models, yeah? Two types of models?
I have not.
I
have not evaluated. So through this hackathon, I just wrote a code to crop the image by polygon. So those are geospatial layers. So I have to overlap precisely in order to crop that.
Okay, so I didn't get that. What's the name of the model that you used for this?
In the future, I'm going to use YOLO version 6.
YOLO version 6?
YOLO, YOLO. Yeah, you once look or something, abbreviation.
Okay, thank you.
Thank you. Thank you for the great question.
Excellent. And Yoko, would you mind stopping your share of your screens? But we have two more questions here. So we had a question from Ali'i, who is asking, what was the name of the invasive fern that you highlighted?
So that is Angiopteris.
All right, thank you. And then we also had someone with their hand up, and it was, oh, where did you go?
It's
there you are.
Montana. Yeah, hi. Thank you so much for the presentation. Really interesting, both the presentations. And my question really for Yoko was around the labeling of the data. I know labeling can be a massive task. I'm curious if you can talk a bit more on, are there automated ways to label the invasive species? You know, if there are broad polygons or if there might be smaller polygons, it could become more challenging. Are there automated ways to do that you might explain?
I hope there is a way to do that, but I haven't seen that yet. And then my future dream is to create a large data set for tropical forest. So one recently I found was a deep forest that consists of a lot of data set with labels, but I haven't seen anything for the tropical forest.
Thank you.
Thank you for asking.
All right. Are there any other questions? Great. Fantastic job, Group Hawaii. Oh, wait, I saw Suzanne come off mute. Did you have a question, Suzanne?
Oh, it's always the challenge. And since we're not face to face, it makes it tough because I'd like to follow on with Vandana's question so that we could get into a conversation about what are analogous kinds of information that we could look at for the polar regions that might be useful for IHARP, and how can things kind of parallel between what Yoko and her team have done and what IHARP is looking to do in the future. But I don't know if we can do that right now.
I think I'll just make one quick comment on that, because the example that Yoko laid out really brought out the example of how we are trying to label, let's say, lakes on the ice sheets. It's very similar to that. So I would love to follow up and have a conversation, Suzanne, and maybe look at more of Yoko's work in the future.
Wonderful.
Excellent. All right. If there aren't any further questions, we will move on to Team Onto-Somethin. So Team Onto-Somethin, the floor is yours.
Ali, that's you.
Yep. I have, I'm sorry. My share button is not working.
Would you like for me to share, because I've got the slides, I can put it up in Google and share it quickly?
Yes, please. Yes,
Okay.
please.
Okay, you'll just have to tell me when you would like for me to change the slides. So one
Okay.
moment, everyone. All right.
Perfect.
I'm not sure how to get it into presentation mode. It's
Top right,
blocking.
top right, and slideshow. There you go.
Got it. Thank you. All right.
All right. Thanks, partner. Hello, Kakoi, everyone. I'm Ali Napoleon, second year data science major at Chaminade University of Honolulu. And we are Team Onto-Somethin. Onto-Somethin is we're tasked with creating a registry for polar and data scientists through the Onto-Soft system. And so we took Onto and put it with something because we're onto something. So our team is Dr. Suzanne Pierce, myself, and Dr. Karen Chen. So we set out with an ambitious goal to describe and highlight at least 25 relevant curricular resources for the IHARP community. And again, the resources would include topics for data scientists and polar sciences. Next slide, please. So IHARP is the Institute for Harnessing Data and Model Revolution in the Polar Regions. On day 2, we set out to create our logic model. And we highlighted first the type of resources that we're going to go after to put into the to the IHARP registry. The activities set forth were the activities that we decided to go with were set forth on this second day as well. And overall, the impact, I think the most important thing that is worth noting is that we wanted to make sure that everything that we put out to the community was well vetted and well explained. Next slide, please. On Wednesday, the 17th, we were able to complete the first set of our activities that we set out to accomplish. Unfortunately, we ran into some issues with user issues and some admin issues with the Onto-Soft system that are currently being addressed. Next slide, please. Thursday, day 4, yesterday, we completed the rest of our tasks. And as you can see, we're well on our way to accomplishing our goals. Next slide, please. So one of the most important and time-consuming things we worked on was getting together our framework and how we were agreeing on how we were going to describe each source that we presented. So we came up with a list of keywords and labels, and we wanted to, most importantly, differentiate between resource materials and teaching materials. Next slide, please. So originally, again, our goal was ambitiously set out to collect 25 and collect and post 25 sources. We unfortunately fell short of the goal. We have 19 of 25. But here you can see is a list of some of the resources that we set out and posted. Next slide, please. So there are six areas to describe, 6 areas of description for every source that's out there. The goal was for us to finish at least the identify part. And though we fell short of our goal of 25, we did indeed were indeed actually to finish the identify category within each description. The identify category, of course, it's the title of the resource, along with a brief description. And on the third topic, you can see, or third area, you can see that we have some of the keywords listed that we to help users find the resource, along with a URL to access the site. Next, please. Once we finished our entering everything into the registry, we then went ahead and entered our work into the GitHub repository. Next slide. And thank you very much. And Suzanne will answer any questions that anyone may have.
And Karen too. So one of the things, thank you so much for presenting. I think we had a lot of discussion about how this would inform iHarp, and really focused in conversations around how do we make this not just a hackathon project, but something that can now start to inform activities that the iHarp community may undertake in the coming year. We realized very quickly when we were in conversations with Dr. Chen that it was important not to just focus on curricular and classroom resources, but to actually think more at the level of constructing a registry for knowledge management, and also making sure that we were identifying materials that were very specifically at that nexus between polar and data science approaches and research and educational resources. So we in some senses narrowed the vision of what iHarp will be looking to do in terms of defining the niche that iHarp has taken on, and also looking at how they'll be able to distinguish themselves as a community from existing platforms and resources and other programs that are already funded and underway. And so in some ways, it's trying to figure out what specifically this community will need. And so we had rich discussions around what that taxonomy of labels and categories and keywords will be. And it can open up a conversation, I think, going forward with the broader iHarp community. And with that, we've got about 3 minutes. So Karen, if you've got any comments, or Alie, if you've got any, or if there are any questions.
Yeah, thank you, Suzanne, and thank you, Ellie, for the presentation. I really love the snowflake. That's exactly our vision, and it's such a joyful experience to work with Suzanne. and Ali and try to make a step into this so-called knowledge management repository. It's pretty ambitious goal. I can see that our goal is to really create something, populate as much possible at the intersection of the Venn diagram. However, so far, we actually most of the material we populated and either policy science and data science, not so much at the intersection yet. But this is a goal that iHeart Present Institute is moving toward. And I'm always thinking about, as an educator, how we can educate the next generation of policy scientists. They are fluent in data science, or data science, they are easy to communicate with policy science. It is a tall order, very challenging task for us. And I'll learn from Dr. Dina Pellington that it is not really multidisciplinary, it is interdisciplinary, and how we can educate the talent with T-shape, pie shape, and what other shape, many different kind of shape, so that we can put all everybody into the shape to solve the problem, challenging problem, the really interdisciplinary arena. Yeah. So it is really just a starting point. As the name say it, we are onto something, but we're not there yet.
Excellent. Excellent job, team. Excellent job. And I'm going to open the floor up to questions one more time, but if you don't mind, this is one of the last times we're, of course, going to meet together as an ISGEO-22 workshop, and we'd love to get a picture. So if possible, if you're in a position that you're able to do this, could you please turn on your cameras so we can see your bright, shiny faces or tired faces, depending upon the team, so that we can take a picture of everyone here. We really appreciate you all being here. And of course, we have one more group that's going to present, but I just want to make sure we get everyone that we can, if possible.
Regarding the knowledge management.
Oh,
Good. Ask the question, ask away, and we can smile while we take a picture.
So if you want, I can ask it after the photo of the
Sure.
All right.
Go, Jimmy. Take that picture.
Daniel had me smiling. I'm sorry. I had to get myself together. All right. I'm looking at the camera. And 1, 2, and one more. Let's do it. 1, 2, 3. Uh-oh. Wait. I got to wait a minute. All right. There we go. All right. And big smile. Think about nap time. There we go. All right. Thank you, everyone.
Thank you.
What was the question?
Okay, so I wanted that is really amazing. I mean, that's very important, and I know that's hard to handle. This is a great project, and thank you so much. But I want to ask that people. So, can people who are working on the iHeart project, can they also add materials to your system?
Yes.
That's good. And also I had a suggestion, because I used to work in knowledge management some years ago, but yeah, I know that there's two types of knowledge, explicit and implicit. So there are some techniques for knowledge management to gain the implicit knowledge of people. And it's just a suggestion for your future phases. I'm not talking about now. But also you can consider that, for example, if for a problem they achieve the best practice or even a modeling, they can record a video of their best practice and running the codes even. Because some people get some tips during working, like a doctor, that maybe maybe you cannot find their knowledge in any books, but in their practice, because of their experience, actually you see that. So that's implicit knowledge that it's not in any resources. So you can find it, you can actually get this information and this knowledge by recording them when they are working. So that can be considered for your future. It's just a suggestion, because I was really impressed with your project. Thank you.
Thank you for that suggestion. I think that's an amazing suggestion. And I totally agree with you. It's at that intersection, it's more craft than documented methodologies or science in many cases that leads to success. And so, yeah, if we're able to work through and have a knowledge management registry and repository for iHarp, the goal is to accelerate so people can actually move faster into their research. So I love your comment about implicit and explicit knowledge, and that's great.
Thank you.
Yeah, thank you, Sarah. And the next time around, we might want to instrument their collaboration session, and I do exactly what you're looking for.
Yeah, that's cool. That'd be a great follow-on for the future.
And I want to throw one more thing out there before we have our last team as well. For those of you that want to play the home game, if you go to, let me open it up here. There we go. If you go to is-geo.github.io/ISGEO-22, you can actually take a look at the different teams' projects themselves. So for instance, for the team that we just saw, Onto-Somethin, if I go up top to project teams, and in project teams, I slide on down to Onto-Somethin, I can actually click on their team GitHub repository, their team GitHub repo. And so there you have the information they have. You have their final presentation. You have more information about the goals and whatnot. But in the case of this team, you even have a link to the iHarp Onto-Soft. Now, don't get me wrong, you do have to have permissions and an account in order to access this link, but that link is there so that you can continue on. So for instance, actually, I'm going to ask, since I was just there, Suzanne, who would they need to contact for access to that Onto-Soft?
Probably Karen or myself. And so what we will do is we'll add that information for who to reach out to gain access. We want to go back to the iHarp research community and make sure that we go through that taxonomy first. And we even want to reach out to the Onto-Soft development team to see about modifying Onto-Soft so that it is better suited for this knowledge registry approach rather than just being specific to software registry. So we've got a couple more steps before we're ready to kind of open up that resource to folks, but we will, and we can add contact. So Karen and I can talk about how we want to manage that, but I appreciate that you're pointing it out, and I appreciate that there's interest in contributing.
Fantastic. So up next, as hinted by our shared screen now, we will have Team Icebreaker. Now, I want to show you something from Team Icebreaker, something I thought was pretty cool. So what Deanna Pennington, one of the things that all the teams did was a logic board and concept map. And I actually added these to the site so we could see them. But the Icebreakers definitely got in there and added that information in there for their team. We actually used a program called Mirrorboard that allowed us to work interactively with that. And even with Team Semanta, or actually I'll come down to Team Hawaii is the one that I think was the one that they really went in deep on this. With the team lead Yoko, they did a very interesting concept map that really lays out everything. So we do want to put that out there for all of those that are joining us, of course, through YouTube and maybe watching this later, that is one of the tools that we used. But having said that, at long last, but not least last, that's not a thing, is it? No, I don't think that's a thing. But we are going to introduce Team Icebreaker. So Team Icebreaker, you have our attention.
Thank you. Good afternoon, everyone. We are Team Icebreaker. Can everyone see my screen?
Yes.
Oh, okay, thank you. So we are Team Icebreaker. Our team members are Chaya, Atifa, Dr. Matthew, Omar, and me. We are actually working on a geoscience data set. Our team goal is to use the machine learning concept or AI concept to map the landscape hidden under the ice sheet. We're actually working on Greenland-based data set. We are trying to predict the ice bed topography of Greenland. Previously, Dr. Matthew's team has done it using physics-based concept, but our team project goal was to predict the ice bed topography using machine learning model. So the question for a hackathon that Matthew gave us for this project is to how we are going to process the input data to train the model. What kind of model are we going to use? And have we done the partitioning, the train data splitting properly? Throughout this presentation and throughout this 5 days workshop, we have tried to answer these questions and we'll present it in here. So our project challenges, we are actually quite, the main challenges of our project was to maintain the data set. We don't come from geospatial data or geological or geoscience background or polar science background. None of our team member comes from that. So we quite a bit struggle with to understand the domain, to understand the data set, to interpret the data set. So our first challenge was to understand the domain, how the features are correlated, how the data are collected, what does this coordinate means or not. And it also comes with data mapping. We need to find out pixel values according to track ice bed topography. It was a quite strenuous process for us to correlate between the point of ice bed topography and find out the corresponding values of other features, and find out a formula that how we can relate between these values and these features. So finally, we have come up with these things. Actually, Jamie and other professors know that our 80% of our time we invested for the data pre-processing. Our data set was quite complex for us because none of us come from, as I previously mentioned, none of us comes from this domain. So let's talk it a little bit of background. The data set we gave, or the problem we gave, comes from ice-based features is composed of ice surface elevation, how the ice speed is how the ice is moving, which means the ice speed, and the thinning rate, which means how much the ice is going below the surface sea level or the under the sea level. Using these features, we have applied machine learning concept to predict a bed topography of the ice bed of Greenland. So our data was collected using an airplane radar concept. So an airplane was gone to the Greenland and the radar was connected with it. So the radar camera took pixels, took images of the ice bed. We are given only the coordinates of those pixels, but there are some missing points in where the radar could not go for that and underneath the ice bed. So we were trying to predict those missing points and find a concept of how the ice bed looks for the Greenland ice sheet. I don't know that much about these theoretical concepts. As far as I can see, we can gain knowledge from Dr. Matthew's presentation. Is that this is a datagram. There is the air, ice thickness, and this is the ocean, and this is the bedrock. I'm not from geoscience, so I cannot explain it properly. These are some of the flight lines that the radar took images using in 2012. These are some lines where the data are taken, like the red ones and the yellow ones, and there are some places like the blue lines where we could not get some data, or they could not get this data. This is our team logic model. Our resources was Greenland H5 dataset, and of course our wonderful team members. They are very cooperative throughout these 5 days of workshop. Thanks to you guys. For our first task was to do some data processing, then did some data analysis, data cleaning. As before I said, it's all about, our project was all about maintaining the data set. And after data cleaning, we did the feature extraction, and finally we went for applying the machine learning model. Our output or metrics was to predict the bed topography, which is the coordinates of the Greenland dataset. And for model evaluation, we use RMSE error. The short-term outcomes was the estimate of the models, then our understanding our bed features, and different kinds of model hyperparameter tuning. So our primary outcome was to gain a knowledge or have a predictive knowledge of how the bed topography looks of Greenland ice sheet. And we hope that we will have some impact on the geoscience knowledge, help them to run a model or to simulate a model of the bed topography. Okay, so let's talk about our data set. Our data set was a 2D grid. It was in HDF5 format. The pixel values that were given as a coordinate, they were 150 meter apart. So there are 4 features. They are surface elevation, ice flow velocity, thinning rates, and snow accumulation. And we have used SURF-X and SURF-Y coordinate values to extract points from these features. That our training point was to work on the track bed training data set. Track bed training points. We extract the X and Y column from track bed training, and for each point we find the corresponding pixels in the input grids from SURF-X and SURF-Y. And then we prepare the input data. In the preparing process of input data, we find the corresponding feature values from each feature, the self elevation, the velocity, the thinning rates, and the accumulation across each point of the track bed training. Then we infer the bed height, and we then made a comparison with our value and calculated the RMSA error. For the training set, we are given a track bed testing. This is also consists of 2 columns, the X and Y coordinates, and we predicted our value of the test data too. So in part of the data pre-processing, first we had to work with the raw data, HDF5 data. Then we find the closest pixel index of the track bed points for each SURF-X and SURF-Y. And in the third step, we find out the corresponding feature values for this DHDT, elevation, bed map, and the velocity corresponding to the pixel index that we get from X and Y. And then after after completing these 3 steps, we get the training data set as hackathon train, and we repeat the process again for our testing data. Now it comes to machine learning model. We have applied a regression analysis based concept machine learning model. The training test splitting is done 70-30. We have applied machine learning for random forest regression. Oh, sorry, it should be decision tree and the linear regressor. So our results, here is our results for the linear regression. We get the RMSA error for linear regression is 146 for training and 147 for testing. The mean value difference between real value and prediction is 360 and 175. For the decision trees, we get the RMSA training value is 146 and for testing is 147. And again, the same, I think it's close to linear. Atifa, is it the same as the decision trees as the linear regression?
It's very close to each other, the result.
Okay, so the mean value is close to decision trees and the linear regression. Yeah, so that's from us. So if you have any questions.
That's great. I have a quick question.
Sure.
Did you talk to Dr. Matthew about this error, the magnitude error? Is it good enough, or know how that this he hasn't sensed the error tolerance? Is it good or?
Oh, okay. So Dr. Matthew is traveling to Greenland, professor. So we couldn't contact him yet. Like he's like on and off in Slack. So
okay. So I have a question. So MAE, it's mean absolute error, right? MSE is okay. So that's why.
Errors,
yeah. So that's why if you take a square root, then it will be more comparable. Otherwise, it looks roomy. Okay, that makes sense. Yeah. Okay, cool. Did you compare to your default model if you just to see
we are not given the solution for this data set.
Yeah, I know, but you can calculate your performance for the error as a default model. So as a baseline model, you want to compare. So as you can see, does the decision tree actually offer any improvement from linear model?
I think we got the almost same results for both the linear regression and the decision trees.
Okay, so
we actually tried grid search, but like since our data set is very big, so we didn't get enough time to run the grid search. It was like running up for almost 45 minutes. So we just have to go for basic model.
Okay, that's great. As a first shot. Awesome.
Thank you.
Oh, thank you for the great presentation. I have a couple of questions.
Yeah.
According to your slide number 8, input data resolution is 150 meters. Does it mean 150 meters spatial resolution? I'm not familiar with radar echogram, so if you can help me understand, that would be great.
Okay, bro. So the idea that I have from this data set is that each pixel is 150 meter. I mean, each pixel coordinate is 150 meter distanced. So if you call it a spatial distance, something like that, yeah.
Okay. And then another question is that, so eventually, final result, you are going to overlay on the map?
Actually, we are not part of that project. I don't know. It's Matthew's idea. How are they gonna mapping our results to their physics model? I don't know about that.
I see. A reason why I asked you is that North Pole area, there are like not enough satellite route. So most of the satellite is going around the Earth, but they don't go right above or close to the North Pole. So it is extremely difficult to geo-tag those data. So I wonder how you are going to accomplish. But I understand. Yeah.
Okay, I don't know actually, but I'm not sure that they're taking those data using satellite. Maybe they are using separate airplanes with a radar connected to take those data. I'm not sure if they're taking using satellite or not.
I see. Thank you very much.
Thank you.
You could have a great question. If I understand correctly, it was the motivation behind this project to extrapolate to the place that the radar was not able to gather data points. But at least right now, we do have the data from some of the line, and we try to see whether we can make a prediction from the ground truth, based on the ground truth, and then if it work well, and hopefully to extrapolate it to other places that is out of region. Yeah, so I do think you can overlay back to the map to see how it looks like.
Yeah, maybe. Yeah,
that sounds great. I look forward to it.
And Vandana, I saw you had your hand up as well.
Yeah, thank you. I think this is very comprehensive and very well done project, and a lot of good data in here. I just have a couple of clarifying questions, and I love Suzanne's question as well about the future plans, because it seems like you're set on a very good path. So my question first, you're really trying to infer the bed height, right, based on your input data. My question is, are there certain attributes that you found were much better at predicting the bed or inferring the bed height as compared to the others?
Okay, so Professor, your question was that, is there any kind of important features that actually impacts to predict our data?
Yeah, if you think of feature ranking, like if you had to do a feature ranking, are there certain features which are more important than others?
We didn't do that kind of analysis in this project so far. We actually used all kinds of features all together. Maybe we have to do our trial and error that which feature impacts the most, but we have not done it.
So maybe this might help. So you did decision trees, right?
Yes.
Yes.
So in the decision tree, you would have the root, which is probably the most important. So what was the root, if you can give me an example? What was the root of the tree? Because that's also ranking in some sense, right? It's ranking based on entropy. If you don't have it, we can follow up, but that would be very interesting to see.
Okay,
because
no, we don't have it here. Okay, we can look into it. We don't have it here now.
it might be useful because to Dr. Chen's question, if you want to extrapolate it to other places where you don't have radar measurements, if you have those specific features, you can actually use those to extrapolate or infer the bed height,
yeah.
if you don't have all of them.
Yeah.
No.
Thank you so much for the
And-
question.
Sure.
And I
Thank
also
you.
think based on what Dr. Mathall was actually saying was that, but there are areas that they know they're going to have issues with actually forming a proper bed, like the calving front. The calving front, because the radar data isn't going to give a very good definition of where the bedrock exists. Having said that, though, I think it was more of the process of proving that it can be done at all, and then they'll go back and really nail it down and fine tune the model and whatnot. And from my point of view, I definitely have to say, first of all, they put in a Herculean effort to get this done in the time they did. One thing I've found out about these hackathons and datathons and things like that is 80% of whatever time you're given is dedicated to formatting the data. You all know that, making the data actually usable. And the same was true here. So the fact that they got anything working as far as in the AI component, I am super impressed. But the future, what Suzanne is saying, Vandana is saying, Dr. Chen is saying, or Karen, what they're saying is that this project has legs. You can see the excitement of it. And so for the Icebreaker team, I just want to say that you all have done I'm going to make up a word, a fantabulous job.
Thank you so much. Thank you to all of my team members. Like, they're being so supportive. Like, we really worked as a team. Thank you so much, all of my team. And I mean, we are a really great team. Maybe we can work forward in another hackathon. I'm really interested to work with them. Thank you so much.
It's excellent. Thank you. All right. So we have made it past our final presentation. So what I'm going to do is I'm actually going to conclude the live streaming component. Before we do, can we just give the teams one more hand? Thank you all so much. You all did an amazing job. Semanta, Hawaii, Icebreaker, and Onto-Somethin. You all did an amazing job. So with that, I'm actually going to end our live stream. So thank you for joining us, live stream people. All 6 of you all, thank you. We're glad to see you all.